The topic that I will discuss is air pollution system. In this day and age, pollution control systems are a must. Air pollutants are generated through both natural, example of natural is volcanic eruptions and wildfires, and human-made sources, including mobile and stationary ones. Mobile refers to moving sources, such as airplanes, trains, and automobiles, while stationary refers to fixed industrial sources such as power plants, factories, and other facilities. Stationary sources are further broken into major and area sources. Major sources emit either 10 or more tons of a single air pollutant or 25 or more tons of a combination of air pollutants. Area sources emit less than 10 tons of a single pollutant or less than 25 tons of a combination of pollutants. In high enough concentrations, the pollutants produced by either mobile or stationary sources could cause adverse effects to the atmosphere, the surrounding environment, and human life, such as increasing the average global temperature, decreasing atmospheric visibility, diminishing air quality, and affecting human health. That is why the Environmental Protection Agency or EPA implemented the Clean Air Act or CAA, which imposed regulations on both sources of air pollutants to help mitigate their effect on the atmosphere, the environment, and human life. The types of pollutants regulated by the EPA are divided into three groups, which include criteria air pollutants, air toxics, and greenhouse gases. First one is criteria air pollutants are a group of 6 common air pollutants. Example of this is particulate matter or PM, photochemical oxidants. Example of this photochemical oxidants is ozone. And next is carbon monoxide, sulfur oxide, nitrogen oxide, and lead, which can negatively affect public health and welfare, the atmosphere and environment, and surrounding structures. Next is the term air toxics refers to a list of over 180 air pollutants. Example of this is organic chemicals, volatile organic compounds or VOCs, metals and metal compounds, including fuels, solvents, mercury, arsenic, asbestos, and benzene, which yield hazardous health and environment effects even when present in trace amounts and produced by fewer sources compared to criteria pollutants. Next is greenhouse gases. Refers to gases including carbon dioxide, chlorofluorocarbons, methane, and ozone, which both affect human health and contribute to the escalation of the greenhouse effect on Earth and the subsequent effect on the global climate. Altogether, the regulations surrounding these different types of air pollutants dictate some of the consideration that industries must keep in mind to remain compliant with the EPA standards, such as implementing the necessary and proper air pollution control equipment and systems, and avoid government repercussions. This article explores the various types of air pollution control equipment available to address stationary sources of air pollutants and explains their respective functions and mechanisms. Additionally, we're going to outline the selection considerations and common applications for each control device, types of air pollution control systems, and equipment, Air pollutants are generated by nearly every facet of the industrial process, including raw material sourcing, product manufacturing, maintenance and repair services, and distribution. Consequently, there are several different types of air pollution control equipment available for air pollutants produced by both mobile and stationary sources across a wide range of industries. However, this article focuses mainly on control equipment for stationary sourced air pollutants such as those produced during combustion processes. In an industrial setting, air pollution control equipment is an umbrella term referring to equipment and systems used to regulate and eliminate the emission of potentially hazardous substances, including particulate matter and gases, produced by manufacturing process system and research applications into the air, atmosphere, and surrounding environment. Control equipment has application in a wide range of industries, preventing the release of chemicals, vapors, and dust, and filtering and purifying the air within the work environment. Um, Typically, fans or blowers direct industrial exhaust and emissions into the air pollution control equipment and systems, which remove or reduce air pollutants through the use of one or more of the following processes: combustion. Example of this is destroying the pollutant; conversion, chemically changing the pollutant to a less harmful compound; collection, removing the pollutant from the waste air before it's released into the environment and atmosphere. Some types of air pollution control equipment applied to industrial applications and which utilize one or more of the methods of air pollutant removal or reduction mentioned above include scrubbers. Some of the most commonly used air pollution control devices in manufacturing and processing facilities. Industrial air scrubbers employ a physical process. Example of this is scrubbing, which removes particulates and gases from industrial emissions, such as smokestack exhaust in the case of exhaust air scrubbers. Before they are released into the atmosphere, there are two main categories of scrubbers: dry scrubbers and wet scrubbers. Dry scrubbers. Dry scrubbers, also referred to as absorption adsorption scrubbers, inject dry neutralizing chemical agents such as sodium bicarbonate into the emission stream, causing the gaseous pollutants contained within to undergo a chemical reaction which either neutralizes the pollutants or converts them into innocuous substances. Once the chemical reaction concludes, filters within the scrubber chamber collect and remove the spent agents from the cleaned emission gas. In some cases, the collected agents can be washed and reused for future dry scrubbing process. But if not possible, the scrubbing waste must be disposed of by specialists. Typically, dry scrubbers are used to remove or counteract acid gas within industrial emissions. The chemical reactions resulting from the addition of neutralizing agents during the dry scrubbing process helps to both reduce the acidity of the emissions and remove air pollutants. Next is wet scrubbers, also referred to as wet adsorption scrubbers or wet collectors. Employ liquid solutions, typically water, to collect and remove water soluble gas and particulate pollutants from industrial emissions. The wet scrubbing process either passes a gas stream through a liquid solution or injects a liquid solution into a gas stream. As the gas stream comes into contact with the liquid, the solution absorbs the pollutant, removing it from the stream. The types of wet scrubbing equipment available include venturi, packed bed or packed towered, and bubbling scrubbers. Next is air filters. Air filters are devices used to control air pollution which employ a specific type of filtration media, like fabric, sintered metal, ceramic, and etc., to collect and remove dry particulates and contaminants such as dust, pollen, microbes, chemicals, and etc. from air passing through them. These devices are utilized in residential, commercial, and industrial applications to remove pollutants from exhaust air and improve the air quality within the work environment. Cartridge dust collectors. Similar to baghouses, cartridge dust collectors are air filters which utilize cartridge filters rather than the filter bags. To collect and remove airborne dust and other particulates, the particulate accumulation on cartridge dust collectors also requires periodic cleaning and removal. While this type of dust collector can attain higher efficiencies than a comparable baghouse depending on the cartridge material, it also be more sensitive to condensation. Next is electrostatic precipitators. Electrostatic precipitators, like air filters and cyclones, are air pollution control devices used to collect and remove particulate matter, such as dust, from industrial emissions and exhaust. Electrostatic precipitators employ transformers to create high static electrical potential difference between charging electrodes and collecting plates. As gas stream pass between the two components, an electrical charge is introduced to the particulates, which attracts the particulate matter to the collecting plates. Similarly to air filters, PM accumulation is periodically removed from the collecting plates and deposited in a collection hopper below, either through mechanically dislodging the particulates or by introducing water to clean off the particulates. Electrostatic precipitators, which employ the latter method, are known as wet electrostatic precipitators. As electrostatic precipitators typically have multiple collection plates, their efficiency often exceeds 99%. Next is mist collectors, also known as a mist or moisture eliminator filters. Mist collectors are air pollution control devices which remove moisture and vapor, like smoke, oil, and mist, from gas streams. These devices employ fine mesh-like filters to separate liquid droplets from the gas and collect them into a separate chamber for further processing and potentially recovery and reuse. Next is incinerators. Incinerators are devices which employ combustion methods to break down pollutants into non-toxic byproducts. While these devices can be used to incinerate wastes in solid, liquid, and gaseous form, they are widely employed in a variety of industrial applications to maintain air quality and regulate gas emissions by converting VOx, hydrocarbons, and other hazardous air pollutants such as HAP into innocuous compounds such as carbon dioxide, nitrogen, and oxygen. Typically, incinerators are succeeded by scrubbers in an air pollution control system, as the scrubbing process removes any additional compounds formed through the combustion process. Next is thermal oxidizer, also known as thermal incinerators. This is devices. These are the devices which employ a combustion process to convert particulate matter and gaseous pollutants such as VOCs, hydrocarbon compounds, and odorous fumes into water vapor, carbon dioxide, and waste heat. Some types of thermal oxidizer are capable of incinerating air pollutants at 99.99% efficiency. Next is catalytic oxidizers. These are incinerators which employ catalyst beds to aid the incineration process for gaseous pollutants and particulate matter. Made of precious or base metal, the catalyst bed lowers the required temperatures for initiating oxidation, accelerating the process and reducing the amount of combustible compounds needed to achieve combustion efficiencies comparable to that of thermal oxidizers. Like thermal oxidizers, catalytic oxidizers are used in industrial applications to break down VOCs, hydrocarbon compounds, and odorous fumes. Some catalytic oxidizers are not suitable for incinerating gas and emissions containing PM, as the particulates can coat the surface of the catalyst bed, preventing the disrupting the oxidation process. Newer catalysts allow catalytic oxidizers to handle most gas and PM compounds. The types of catalytic oxidizers include regenerative catalytic oxidizers or RCO and recuperative catalytic oxidizers. Next is biofilters. Biofilters are air pollution control devices which employ microorganisms such as bacteria and fungi to degrade and remove water-soluble compounds. Similarly to incineration devices, biofilters destroy the pollutants to reduce the amount present in industrial emission and exhaust. However, the microorganism in biofilters absorb and metabolize gaseous pollutants such as VOCs and organic HAP without generating byproducts typically produced through combustion such as NO and CO. These devices are capable of achieving over 98% efficiencies. Auxiliary equipment. A complete air pollution control system refers not only to the equipment which destroys, chemically changes, or collects the pollutants and emissions, like scrubbers, filters, and incinerators, but the components and equipment which make up the system's infrastructure and provide support to the control equipment as well. Some of the standard auxiliary components and equipment: monitoring and pollution control systems. Monitoring and control systems such as continuous emission monitoring systems or CEMS allow companies to monitor, control, and record their emission levels. By doing so, they can better track their emissions output and system efficiency, as well as update their systems accordingly to better align with environmental or budgetary standards. Next is fans and blowers. Fans and blowers are incorporated into air pollution control system to help draw and direct industrial exhaust and emissions into the air pollution control equipment for pollutant filtration and removal, as well as to help guide the clean, filtered air out of the equipment. Next is blade dampers. Blade dampers can be used to control and regulate airflow within air pollution control systems. These devices are available in manually or automatically operated designs as well as employ electrical and or pneumatic actuators to open and close the device's blades. There are two main types of dampers available: parallel and opposed blade dampers, each of which is suited for different specifications and requirements. The next one is stocks. Once industrial emissions are processed by the air pollution control equipment employed, the processed emissions are generally released into the atmosphere. Stocks provide an outlet through which the emissions are dispersed into the atmosphere, as well as prevent the emissions from re-entering the building. Additionally, stocks produce a natural draft which aids, when applicable, combustion processes. Next one is heat exchangers. These can be used within waste heat recovery systems. By employing waste heat recovery systems, air pollution control systems can improve the energy and operating efficiency of their equipment. This characteristic is especially useful for control devices which employ the combustion method of pollutant removal, such as thermal oxidizers. Um, Pollution control system or selection considerations. While there are a wide variety of air pollution control equipment and systems available, the suitability of each type in mitigating the amount of chemicals, vapors, and dust emitted into the atmosphere and filtering and purifying the air within the work environment is dependent on several factors. Some consideration that industry professionals should keep in mind when choosing an air pollution control device include the type or types of air pollutant or pollutants needing removal. Second one is pollutant removal and reduction efficiency. And for reference, this is the reference of my research, and that's all. Thank you.